Hi students, today we are going to see a problem in development of solid, a square pyramid. So here we'll be using radial line method. In last class we saw parallel line method for solving a cylinder. Since it is for prism and cylinder, we'll be using parallel line methods, whereas for a cone and a pyramid we'll be using radial line method. I'll read out the question and go to the problem. A square pyramid has a base side of 40 mm and altitude 80 mm. It rests with its base on HP such that one side of the base is inclined at 30 degree. The pyramid is cut by, so this is about the solid. Now it is about the cutting plane. The pyramid is cut by a plane which bisects the axis and inclined at 45 degree to HP. Draw the development of remaining portion of the solid. So here the first few lines is about the solid. They say the base is resting on HP. Normally for development of solid, the base will be resting on HP, so that we'll be drawing the top view on HP and front view on VP. So at what orientation we have to draw? So they have said one side is inclined at an angle of 30 degree. This alone we have to check. So it may be one side parallel to VP or one side perpendicular to VP. So imagine this is a solid. So this is a triangular pyramid. So imagine one side is, so one of the base side is inclined. Also we have to place a solid as such. One of the base side is inclined at an angle of 30 degree to VP. So this is how we have to draw. So can you understand? In some cases they will say one of the base side is perpendicular. By means you have to keep one of the base side perpendicular to VP, or else one of the base side parallel to VP, and then you have to draw. In this case they said one of the base side is inclined at an angle of 30 degree. So we have to keep in such a way and draw the triangular pyramid. So I'll take another paper, or else I'll turn the page here. So you initially start by drawing the XY line. So this is your X and Y. So it'll be here. Then so one of the base side is inclined at an angle of 30 degrees. So mark any point on the line and keep the protector as such and take 30 degree and join the line. So by means we made one of the base side inclined at an angle of 30 degree. You can start from any point. It's not necessarily you have to start exactly at here. You can give some space and take, so the side dimension is 40, and from any point you're going to take 40. So let me take from here, and I'm going to take 40. So 40 is here. Then I have to draw, simply have to draw perpendicular lines. Okay, for each and every point. Since it is a square pyramid, if I draw a perpendicular line, that is going to be sufficient. Okay, so perpendicular lines. So 40 is here. Okay. Now take exactly 4 centimeter. It is 40 mm in your compass. From here, cut an arc. Similarly from here, cut an arc. Now join the point. The solid is completed, and we have to find the center. Just because it is a pyramid, so all the side edges will be pointing towards the center. So we have to find the center and draw the side edges. and this is complete. Now we have drawn the solid. The base edge inclined at an angle of 30 degree. So let me give the dimension. Let me start from here, A. So I have to use only small letters. So that is A, B, C and D. So now I have to draw the front view. To draw the front view, so let me draw projecting lines from each and every point. So I have drawn the projecting lines. Here if you see, the axis is not coinciding with any of the visible corner or as well as invisible corner. So you have to draw the axis line. So axis height is 80 mm. So axis height so I have drawn the axis, then simply just join all the corners just because it is a pyramid. Okay, now the solid is completed. The front view and top view is completed. Now we have to do the notations. So this point is A, so this point is going to be A dash, and this is O, and this is B, and this point is going to be B dash, and this is C, and this is C dash. And if I see from here, this D point is going to be invisible, so I have to put this D dash inside a bracket, and this is going to be O dash. Your solid is completed. So the positioning of the solid, the orientation of the solid is completed. Now we are going to draw the cutting plane. They say so wherever the cutting plane is perpendicular, there you're going to draw the cutting plane. The pyramid is cut by a plane which bisects the axis. Bisect the axis in the sense the total height is 80 mm. So exactly at 40 mm you're going to cut the solid. So this is a bisecting point. So 40 mm at an angle of 45 degree to HP. So from this point you take 45 degree. So 45 degree. Okay. Then simply draw a line. Join these two. So wherever the cutting plane is passing through the solid, it should be a straight line, then a small dash on either side and a big dash which is supposed to be double dark. So your cutting plane is over. Now we have to do the dimensioning for the cutting plane. So as I told you in the last video, so here here we have only one side edge, here we have one side edge, and all the places we have only one side edge. When we travel from left to right, we have to finish all the visible corners. Then we have to, when we are coming back, we have to finish all the invisible corner. Here AO is visible, so 1 dash, and D, this is invisible. Just because I put inside a bracket, it is invisible. You have to finish this only when you are coming back. Okay, so left to right we have to go. We have finished all the visible corners, and while coming back we have to finish all the invisible portion. So here BO is 2 and CO is 3 dash, and this is going to be 4 dash. Now we are going to draw the development of this portion. Here if you see, all the side edges are not equal to each other. So if you see, this dimension is not going to be equal to this thing, as well as this dimension is not going to be equal to this side edge, and even this side edge is not going to be equal. If you see, if you use your compass and check, you can find, because none of the base edges, okay, none of the side edges is parallel to VP. Only if any one of the side edges parallel to VP, we will be having a true inclined length. So what we have to do in this case, we have to make any one of the side edge parallel to VP, then we have to take this dimension, and this will give you the true slant length. So how to do? Just draw a horizontal line, make sure this line is exactly parallel to your VP. Just draw a line, then take your compass, take any one of the side edge. From here, just draw a arc. So there's not going to be much of a difference, but then engineering graphics, it's all about accurate dimension. So this is going to give you the true slant length. Almost both are same. So the next step you are going to do, take this dimension in your compass. Okay, take any point. So this dimension will give you the true slant length, and draw an arc simply. So mark this point. So let this point be O. Now simply draw a line at anywhere in the arc. Now what you're going to do, take the side dimension in your compass, that is 40 mm in your compass, and draw 4 consecutive arcs. 1, 2, 3 and 4. Now join all the points. Make sure you join very lightly, don't use, you're supposed to use only 2H pencil. Join. So now this is the development of the triangular, square pyramid. All the side edges or base edges are going to be straight line. Okay. Now the last step is going to be very easy. From the base, take the dimension 1, which is in between AO. So we have to give the dimension. So this is going to be A, this is going to be B, this is going to be C, D, again A. So take the dimension from 1 is in between OA, so base 2, take this dimension and mark the point. This is going to be 1 for us. Similarly, from D to 4, take this dimension. This is in between DO. DO is supposed to be here, so this is going to be 4. And BO, take this dimension in your compass, that is BO. This is going to be 2. And CO, this is going to be 3. And this is going to be 3. Again we have O. A. For this, from here to here, take this dimension in your compass and transfer here. Now simply join all the points. So this point is going to be 1, this is also 1.